Hi everyone, thanks for watching. Stephen from Clutch Pythons here. We're going to continue our genetics series and dive into a little bit of some more complicated genetics. I suggest you go look at other videos talking about genetics before you look at me. Look at my previous video because I go into some basic dominant recessive genetics and the punnett square. We're going to look at some more of the punnett square today, and we're really going to be looking at the incomplete dominant, or in Herper's terms, codominant traits in ball pythons. All right, guys, I am at my computer and let's just dive right into this. So as you can see, I've got my Excel spreadsheet open today, and we're going to be looking at incomplete dominance. Now, in snakes, incomplete dominance is really important. They also call it codominant, but I prefer incomplete dominance because that's the standard term. Basically, what it is like when you talk about dominant recessive traits, generally you need 2 copies of a recessive gene in order to actually see the effect of that gene in an animal. However, when it comes to incomplete dominant traits, you only need 1 copy of the gene to be visually represented in the animal. But when you add 2 copies of the gene to a ball python, then it has, in some cases, a very big dramatic effect. Not always, but a lot of times the effect is at least greater. And what's cool is in ball pythons, you can add incomplete dominant traits together, and a lot of times they'll kind of battle it out to see which one is going to be visually represented more, and so you get some just amazing combinations. What's cool about incomplete dominant traits is you can also add them to recessive traits and get the visual recessive trait still coming out, but then you have a nice effect with the incomplete dominant traits coming out. It's pretty amazing. So let's just dive in to a little bit of these incomplete dominant traits. So right here is, let's pull up just what a normal ball python looks like. Ball python, browse the latest. Let's just do least expensive. And here we go. This is what a normal ball python looks like if you were to find it in the wild. Let's move that over here. And when you add pastel to it, the pastel really brightens it up. Pastel is an incomplete dominant trait. So let's figure out how this works, because it's different than a recessive trait. Not necessarily in the percentages, but it's different because as long as you have 1 copy of the pastel gene or an incomplete dominant gene in there, you'll always be able to see that it's there most of the time. So we've got our punnett square here. Let's just type it in. So we've got big N at the top. That's a completely normal ball python, one that you would find in the wild. And then on the side, we've got a big P, big N. The big P is representing the pastel gene, and it really overpowers the normal gene. But because we have 2 pairs of chromosome, we have to include the N in there, the big N in there, because it plays a big part in it. So let's type in the results into our punnett square and see what we get. So we get big P, big N, big P, big N, big N, big N, big N, big N. Okay. So by looking at these numbers, we can see that these are our results. Obviously, 50% are going to have the pastel gene, and they're going to have pastel. They're going to visually be represented. And then 50% of the babies will not. They won't have the pastel gene in, and you'll know that they don't because they don't look it. Let's move on down the line to our next breeding set. In our next breeding set, we've got a pastel for the mom and a pastel for the dad. let's see what the results are. Big B, big P, big P, big N, big P, big N, big N, big N. So our most common trait is going to be the pastel. 2 out of 4. If you cross a pastel with a pastel, 2 of them are going to be pastel. 25% will be normal, but this is really cool. 25% will, each pair of chromosomes will have the pastel gene on it. And when it comes to incomplete dominance, in the herper world, we say if a ball python is homozygous for the pastel gene, meaning both genes have the pastel, then we call it super. So that would be a super pastel. And let's just take a look to see what a super pastel. So here's a pastel. And here's a super pastel. You can see with adding both copies of the pastel gene, it really blows out the color. It's very white, and it's really easy to identify when you're breeding ball pythons that the super pastel gene, the super pastel is in there. So really, really cool. Now what's cool is if you have a super pastel ball python, regardless of what you breed it to, it's going to pass one of the pastel genes down because both copies of the chromosome have the pastel gene. And so all of the babies will be visually pastel. Super, super cool. So what do you get if you breed a super pastel to a regular pastel ball python? Let's type it in. So here are the results. 50% will be pastel and 50% will be super pastel. Lots of fun. And as you get in more complicated genes, it's fun to see how your results will pan out. Of course, if you breed 2 super pastels together, 100% of the babies will be super pastel. Now, I want to introduce a new gene to you, and it's called the GHI. The GHI is one of the most popular and sought after genes in ball pythons. GHI stands for gotta have it, and it's for good reason. So let's just take a look here. So here's a pastel. Normal, pastel. Here's what the GHI looks like. It really jumbles up the pattern a little bit, quite a bit. Brings in a lot of darkness and a lot of contrast. Really, really cool in ball pythons. But what will happen if you breed a GHI to a pastel where they're both incomplete dominant traits, but they're different genes? So let's type it in. We've got our punnett square here. For the first result, we're going to get a pastel GHI. In our second result, we're going to get a GHI normal, so just a regular GHI. In our third result, we're going to get a pastel. And then in our fourth result, we're going to get just a normal. So let's type our results in. 25% in all of the pairings is what you will theoretically have from your babies. You'll have a pastel GHI, a GHI, a pastel, and a normal. If you had 4 eggs, theoretically, those are the results that you would get. But what does a GHI, a pastel GHI look like? This is one of my favorites. So you have the pastel, the GHI. When you cross them together, you get the pastel GHI, and it is one of the highest contrast ball pythons that you're going to find, and it is beautiful. People pay big money for beautiful ball pythons. And even though pastel GHI is one of the simplest, it is one of the most sought after just because it looks so amazing. So in our next video, we're going to cover a little bit more advanced genetics. We're going to talk about crossing. Well, what do you get when you cross like a GHI pastel to a GHI pastel? What would you get then? What would the results be? What are the odds? And we'll talk about it in our next video. If you like this video, guys, please subscribe. This has been Steven from Clutch Pythons. Thanks for watching.